Chapter 3A.2 The Nervous System. What are the functions of the nervous system's main divisions? To live is to take in information from the world and the body's tissues, to make decisions, and to send back information and orders to the body's tissues. All this happens thanks to our body's speedy electrochemical communications network, our nervous system, figure 3.7. The brain and spinal cord form the central nervous system, CNS, which communicates with the body's sensory receptors, muscles, and glands via the peripheral nervous system, PNS. Neurons are the nervous system's building blocks. PNS information travels through axons that are bundled into the electrical cables we know as nerves. The optic nerve, for example, bundles 1 million axon fibers into a single cable, carrying the messages each eye sends to the brain. Mason and Candle, 1991. As noted earlier, information travels in the nervous system through sensory neurons, motor neurons, and interneurons. 3A.2.1 The Peripheral Nervous System. Our peripheral nervous system has two components, somatic and autonomic. Our somatic nervous system enables voluntary control of our skeletal muscles. As the bell signals the end of class, your somatic nervous system reports to your brain the current state of your skeletal muscles and carries instructions back, triggering your body to rise from your seat. Our autonomic nervous system controls our glands and the muscles of our internal organs, influencing such functions as glandular activity, heartbeat, and digestion. Like an automatic pilot, this system may be consciously overridden, but usually it operates on its own, autonomously. The autonomic nervous system serves two important basic functions. The sympathetic nervous system arouses and expends energy. If something alarms, enrages, or challenges you, such as taking the AP psychology exam, your sympathetic system will accelerate your heartbeat, raise your blood pressure, slow your digestion, raise your blood sugar, and cool you with perspiration, making you alert and ready for action. Figure 3.8. When the stress subsides, your parasympathetic nervous system produces the opposite effects. It conserves energy as it calms you by decreasing your heartbeat, lowering your blood sugar, and so forth. In everyday situations, the sympathetic and parasympathetic nervous systems work together to keep you in a steady internal state. Section 3A.2.2 The Central Nervous System. From the simplicity of neurons talking to other neurons arises the complexity of the central nervous system's brain and spinal cord. Stephen Colbert said, "How does the brain work? 5 words or less." Neuroscientist Steven Pinker says, "Brain cells fire in patterns." The Colbert Report, February 8, 2007. It is the brain that enables our humanity, our thinking, feeling, and acting. Tens of billions of neurons, each communicating with thousands of other neurons, yield an ever-changing wiring diagram that dwarfs a powerful computer. With some 40 billion neurons, each having roughly 10,000 contacts with other neurons, we end up with perhaps 400 trillion synapses, places where neurons meet and greet their neighbors. DeCourton-Myers, 2005. A grain of sand-sized speck of your brain contains some 100,000 neurons and 1 billion talking synapses. Ramachandran and Blakesley, 1998. The brain's neurons cluster into work groups called neural networks. To understand why, Stephen Kosslyn and Olivier Koenig in 1992 on page 12 invite us to think about why cities exist. Why don't people distribute themselves more evenly across the countryside? Like people networking with people, neurons network with nearby neurons with which they can have short, fast connections. As in figure 3.9, the cells in each layer of a neural network connect with various cells in the next layer. Learning occurs as feedback strengthens connections. Learning to play the violin, for example, builds neural connections. Neurons that fire together, wire together. The spinal cord is an information highway connecting the peripheral nervous system to the brain. Ascending neural fibers send up sensory information, and descending fibers send back motor control information. The neural pathways governing our reflexes, our automatic responses to stimuli, illustrate the spinal cord's work. A simple spinal reflex pathway is composed of a single sensory neuron and a single motor neuron. These often communicate through an interneuron. The knee-jerk response, for example, involves one such simple pathway. A headless warm body could do it. Another such pathway enables the pain reflex, figure 3.10. When your finger touches a flame, neural activity excited by the heat travels via sensory neurons to interneurons in your spinal cord. These interneurons respond by activating motor neurons leading to the muscles in your arm. Because the simple pain reflex pathway runs through the spinal cord and right back out, your hand jerks from the candle's flame before your brain receives and responds to the information that causes you to feel pain. That's why it feels as if your hand jerks away, not by your choice, but on its own. As William James said in the Principles of Psychology in 1890, if the nervous system be cut off between the brain and other parts, the experiences of those other parts are non-existent for the mind. The eye is blind, the ear deaf, the hand insensible and motionless. Information travels to and from the brain by way of the spinal cord. Were the top of your spinal cord severed, you would not feel pain from your paralyzed body below, nor would you feel pleasure. With your brain literally out of touch with your body, you would lose all sensation and voluntary movement in body regions with sensory and motor connections to the spinal cord below its point of injury. You would exhibit the knee jerk without feeling the tap. To produce bodily pain or pleasure, the sensory information must reach the brain. Before you move on, ask yourself, does our nervous system's design, with its synaptic gaps that chemical messenger molecules cross in an imperceptibly brief instant, surprise you? Would you have designed yourself differently? Test yourself too. How does information flow through your nervous system as you pick up a fork? Can you summarize this process?